Carrying on with trigonometry from yesterday, today I want to recap common trig values and sine of obtuse and reflex angles. But before we do that, I would like you to pause the video and have a go at drawing the graph of sine between negative 180 and negative 360 and positive 360 degrees, please, with all the important parts labelled. I am going to do the same. So you pause and have a go. Right, so I always start with the right-hand side. This will not be particularly neat or regular, but it should be. So right-hand side will look like this. Left-hand side will be the same pattern repeated, and this is where, on my graphs, it always goes wrong. That's not so bad, is it? That's all right. Okay, so important information to record then is going to be that this minimum value it can take here is y equals -1, and this maximum value it can take here is y equals +1. This is 360 degrees. This is negative 360 degrees. And this is a regular wave, so this is negative 180. And this is positive 180. This peak is at 90 degrees, and this trough is at negative 90 degrees, which makes this one at 270 degrees because of the regular nature, and this one at negative 270 degrees. So this is the graph, and we should really label our axes, of y equals sine x. So check yours against that, please, and fill in any missing key information. Okay, so recapping common trig values. For your GCSE, you will need to know sine, cos and tan of some particular angles. So we've been through this before. Start with sine, and you don't really need to remember any of the others. We need to know them for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. If you want to write those down for sine and you have no idea, just start with 0 and count. So 0, 1, 2, 3, 4. Square root each of those numbers. And then divide by 2. Those are your values of sine of this angle, sine of this angle, sine of this angle, etc. However, we can obviously simplify some of these. Square root of 0 is 0. Divided by 2 is still 0. So this is 0. Square root of 1 is just 1. Over 2 gives us a half. Root 2 over 2, it is just root 2 over 2 still, but the unrationalised one would be 1 over root 2, so they are equivalent. Root 3 over 2 we can't do anything with, but I just want to make it a little bit smaller. So root 3 over 2. And finally, square root of 4 is 2, divided by 2 is 1. And those are my values of sine 0, sine 30, sine 45, sine 60 and sine 90. If I want to do cos, it's exactly the same values, but I reverse them. So I'm going to write them backwards. So 1, then root 3 over 2, then root 2 over 2, or 1 over root 2, then a half, and then 0. So it's the same values of sine, but backwards. Last one is tan. Tan is sine divided by cos. So tan 0 is 0 divided by 1, that's 0. Tan 30 is a half divided by root 3 over 2. Now, if I have a fraction and I divide it by a fraction with the same denominator, I can ignore the denominators. It's the same as 1 divided by root 3. So here I will get 1 over root 3, which rationalised would be root 3 over 3. Root 2 over 2 divided by root 2 over 2, it's a number divided by itself, so that is 1. Root 3 over 2 divided by 1 over 2. These are both fractions with the same denominator, so I ignore the denominator and it's root 3 over 1, which actually is just root 3. Then finally, 1 divided by 0, can't do it. So we don't actually need to know what tan 90 is. So those are our common trig values. You should copy those out. You should start learning them, maybe put them on flashcards, or learn the method for finding sine, and then remember that cos is the same thing backwards. Tan is sine divided by cos. I don't remember any of these. You know my memory is terrible. I always do this and then work them out. It doesn't take very long. Okay, so the worksheet that I've uploaded called Common Trig Values, I'm now going to go through question 1A and 1B with you to show you how to do these, and then you're going to do the rest of the questions. So, question 1A. It says, use your calculator. Sorry, no it doesn't. Don't use your calculator. So it says, without using your calculator, find the size of the angles marked with letters. So we want to find the size of angle A, but we cannot use our calculators. We are going to use normal trigonometry. No sine rule, no cosine rule, just standard trig. We want this angle, and we've got the hypotenuse and the opposite. So we know that sine of this angle is equal to root 3 over 2. If we look at our common trig values, sine root 3 over 2, the angle must be 60. So A equals 60 degrees. So we're just using the table that we've drawn to help us find the exact size of the angles. Part B. We've got 1, root 2 and B. Now again, we can't use our calculators, so we've got the hypotenuse and we've got the adjacent. So we know that sine B equals adjacent over hypotenuse. And then we look at our table, or you might have just memorised them. Cos 1 over root 2, so it must be 45 degrees. So that means the angle B is 45 degrees. That should be enough for you to have a go at the questions I've put up on common trig values. So have a go at those, pause the video now and have a go, and then play the video again to go through sine of obtuse and reflex angles. For finding obtuse and reflex angles when we're using sine x, we can use the symmetry of the graph, or we can just remember what to do. I like using the symmetry of the graph because, again, memory. But if you like to just have a technique to apply, then we'll talk about that as well. The angles here, so if this is the graph y equals sine x, the angles here up to 90 degrees are all acute, and then we get to right angles. From 90 to 180, we've got obtuse angles. And then from 180 to 360, we've got our reflex angles. When you are working with your calculator, it generally gives you angles between -90 and 90 degrees. If you want to find angles outside of that range, you will usually have to add or subtract from 180 or 360. So let's have a look at an example and I will show you what to do. So this example is going to be for acute and obtuse angles. So this is example 1 on the sheet that I've uploaded, and it is find the two values. Don't worry, that was just my board falling down. Find the two values of x in the range 0 is less than or equal to x is less than or equal to 180, for which sine x equals 0.85. So calculators are useful here, and we're going to use our calculator to find the first value. So there are two values. The first value, we're just going to do sine inverse of 0.85, and that gives us 58.2 degrees to 1 decimal place. So there's one answer, but that is the only answer that the calculator is going to give us. So if we have a look at this graph, 58.2 degrees is roughly here. And it's when this gap from the origin is 58.2. That is going to occur again over here. These have the same value of y. And because this is symmetrical, that value is going to occur when this gap is 58.2. So what we're going to do is 180 minus 58.2, which will take us down to where sine x is equal to 0.85 again. So if we've got an acute angle and we're looking for an obtuse angle, we just subtract the acute angle from 180. So 180 minus 58.2 gives us 121.8 degrees to 1 decimal place again. So if you've got an acute angle and you want to get the other obtuse angle, you just subtract the acute one from 180 degrees. For the next example I'm going to do, this is actually question 2a on the sheet I've put up, and it is finding both values of x in the range 180 to 360 such that sine x equals negative 0.36. So this is actually, it's above 180 degrees, so we are looking at reflex angles. We're still going to use our calculator to help us out. We're going to do sine inverse of negative 0.36, and that will give us negative 21.1 degrees to 1 decimal place. Now this is not in this range, so this doesn't count as one of our answers, but it will help us out. Let's have a look at how. So we have got negative 21.1 degrees. So negative 21.1, that's about here. So this is the value of x our calculator's given us. But that's no good because we want values in between 180 and 360. So if we have a look at where else sine x is going to equal this value, it would be here and it would be here. Now this gap is 21.1, which means that this gap is 21.1 and this gap is 21.1. If we take the negative angle that we've got and we add it to 360, so a negative add 360, it will actually take us down to here. So we can do 360 minus 21.1, so we're adding negative 21.1, which is the same as subtracting it. And we can do 180 minus negative 21.1, which ends up being the same as adding the absolute value. So we can either think of it as subtracting the absolute value or just adding the angle on to 360. And we can think of it as subtracting the angle or adding the absolute value to 180. If we do that, we're going to get 338.9 degrees here. And we are going to get 201.1 degrees here. And those would be our two angles that lie in this range that give us sine x equals negative 0.36. We can check that on our calculators. So if you put sine of 338.9 degrees in, you should get negative 0.36. And if we do sine of 201.1, you should get negative 0.36. So that should now give you enough information to do the sheet on sine of obtuse and reflex angles. So have a go and let me know if you get stuck.